Welcome to the Profiled Corner. Today's video is an introduction to woodworking routers and profiling edges of boards will be one of the topics that we'll be talking about in this video. In front of me, I have a series of different routers that I purchased over the years. And I started out originally with a Craftsman 1.5 horsepower router, but that router failed on me several times in 1990 and 1991, and it was replaced. So in front of me I have a Bosch 1611 EVS router that originally cost $234, and that's $565 in today's dollars. A Milwaukee 2 horsepower router, which originally cost $225 in 1991, and that is $525 in today's dollars. I have a Portacable D-handle router that I purchased in 2001. This is kind of nice because it has a trigger built into the handle. In the mid-2000s, I purchased this Milwaukee 1 3/4 horsepower body grip router. And the nice thing about it is you can use it like a giant palm router. It also comes in a 2 1/4 horsepower rating. And then I purchased this trim router, which is also called a palm router, and it has a laminate trim bit in it right now, which is what I used it for in the past. This is my latest purchase. It's a Bosch cordless trim router or palm router. It has a 4 amp hour battery on the top. In my opinion, these are not suitable for home woodworking shops because this has a vacuum hookup, and if you've got a vacuum hooked up to it, you might as well hook up a cord to it as well. So anyway, we'll go through some of the reasons why I don't think that battery-powered routers are suitable for home woodworking shops later on in the video. So I've got this board here that I cut out on the bandsaw, and I've got another board right here also that was cut on the bandsaw. The one over here on the left was actually sanded after it was cut on the bandsaw. So this has got smooth edges. This is a redwood board. It was reclaimed wood. Originally it was siding on somebody's house, and I've reclaimed it for this project. But this is another board that was rough cut on the bandsaw, and I'm going to make a duplicate of this board on this board. So I'll be doing that in just a moment. I will not be speaking while I'm doing it, and I'll be positioning the camera so that it's focused close on the cut rather on me. So we'll be doing that in a moment. And instead of using black walnut in today's video, I thought it would be a good theme to use some redwood, because redwood costs about as much as black walnut. It's a good wood to use in the video. Okay, so in addition to these routers, I also have a series of woodworking router bits in front of me. Many of these router bits are Whiteside brand. I'm not sponsored by Whiteside. However, I have spent quite a bit of money on Whiteside router bits because I expect to use the best router bits that I can get my hands on, so that I avoid various problems that we'll talk about later on. I'm going to get what's in front of me cleared out. Before I do that, I'm going to take the camera and sweep across everything that I have here in front of me so that you can see all the different types of things we'll be talking about in this router series. This is part 1 of the router series on how to use a router effectively in your shop. I started using routers roughly 40 years ago, and I don't know everything there is about routers, but I know quite a bit. And I'm sure that I could learn some more from watching various videos on YouTube. As a matter of fact, YouTube has been serving up a wide range of beginner router videos to me. It served up to me the New Yankee Woodshop's router series that originally aired on PBS many years ago. That was an excellent video if you get a chance to watch it. There's also some other YouTube videos that are excellent on woodworking routers, and there's some videos that are directed at beginners from expert woodworkers that contain bad information, or information that I think is less than accurate, information that you can't follow religiously. I'll have a computer-generated voice reading back some of those mentions of things that you should or should not do with a router, and you think about whether or not these are accurate while you watch me use the router in front of the camera. So I'm going to remove all of this after I take a quick sweep across everything that's in front of me, and then I'll get set up for cutting into these boards.
Various quotes from YouTube videos. Are these statements true or false? A router has a secondary lock on the collet to keep the router bit from falling out of the collet. That is why you have to use the wrenches twice to remove a router bit from the collet. One of the things you never want to do with a router is freehand cutting. It is very hard to get a straight line or a nice curve. If we run the router in the wrong direction, it can get away from us. What do you do if the grain tells you to route in one direction, but that is different from the direction that the router says you must go? Well, you go in the direction the router says to go, but in small sections. You really can't plunge with a fixed base router. I suppose that you could do it, but it is not safe because the router will try to walk across the wood because you don't have good contact with the surface.
Well, that was a fun little project. As you can see here, we routed around the edge using a classical bit. I used an old, actually it's a 34-year-old plunge router to cut out this little key and this little key. And then I used what's called a fixed base router to cut this out. And for this one, I actually used a bowl cutting bit. It's a specially shaped bit designed for cutting out bowls using a template. As you saw, I had no difficulty controlling that Milwaukee Bondi Grip router when I was going into this board, even though it's a fixed base router. When I was routing these edges here, you may have noticed something that's a little strange. Normally, when you route around a board, you start on the end grain and you work your way around, and then you, in a very smooth motion, you keep moving in the same direction, counterclockwise, around the board. You'll notice, if you watch the video, when I cut this part right here, I was watching the grain here. If I kept going straight, what's going to happen is that this grain is going to try to rip out. And so one way that you can work around that is by doing something called a climb cut. So instead of going counterclockwise around the board, I switched directions and I went clockwise just for a short little point here. And you can do that to work around difficult grain. Normally you do not do climb cuts with a router. When you do, make sure that you have a good grip of the router, because it's going to try to self-feed itself this direction, because the router bit spins clockwise when you're looking down at the router. And that's why you normally have to go counterclockwise when you're routing around the edge of the board. Now if you've got a large pocket in here, you actually have to kind of reverse direction, and you would be going, instead of going this way through a pocket, a large pocket, you would have to actually go this direction if there was a large pocket in here on the inside. Now when you've got this on a router table, things are a little bit different. Instead of passing the router this way, you would actually have to feed the board this way through the router. If you're going to be routing this back edge back here, you would pass the board in the direction that you'd normally pass the router when the router is passing over the top. So that's a little bit about the correct feed direction, and sometimes you have to go in what's called the incorrect feed direction, or climb cutting, for various cuts. And you may have noticed that I was doing a little bit of that on the inside here. I was being careful regarding which direction I went. So when I was cutting this portion here, I didn't try to climb up that, because redwood will split out very easily if you're not careful. And so what I did was I reversed direction. I went down this direction here. On this other side, I was able to go down because there wouldn't be any grain splitting out. And the same over here when I was using the bowl bit. I wouldn't come up this direction, but instead I went down this direction. And then for this, I went down this direction, because coming up this direction could cause this area of the board to split out. Redwood, once again, is very prone to splitting if you're not careful in what you're doing. And there's some other woods that are like that too. Walnut is less likely to split out. So what I did here at the start was I used double stick tape to attach the bottom of the board to be cut to my template board. And then I used a flush bearing bit, it's actually called a flush cutting bit, to run around this template and produce an edge here that had the same profile. So that was a really simple example of what you can do with a router just with a little bit of know-how. And it doesn't take much. I was cutting these freehand, as you can recall, there's a way that you can actually do it using a template. And the template is over here. And then there's a kit that you can mount into the router that will actually follow this outline so that it cuts it very, very precisely. So then you could actually cut another patch out of another board and then insert that patch into this if you're looking for a little bit of a decoration in a board, or if you've got a split in this board, you would be able to put in what's sometimes called a Dutchman into this area here using another board as a sacrificial piece that would then be inserted in. So you can do that using a template kit, and we'll be looking at those in a later video. What I'd like to talk to you about now are a little bit of information about routers. Routers obviously haven't been around for hundreds of years. Instead, there were mechanical means to manually create what the router could create. This is a Stanley number 45. It's a very rare molding plane. This one was actually patented in 1901, if I recall correctly. There was a stamp on here that said patented in 1901. So this is a Stanley number 45, and this was designed to cut profiles into boards. And this took the place of wooden planes that did the same purpose. This has an interchangeable cutter that goes into it. And I've got other cutters in this box. Here's the box for it. I've got other cutters in the box that allow to change the profile of what gets cut. Here's all the different included profiles for it. I'll bring it over closer to the camera so that you can see. So these are all the different profiles that work in the Stanley 45. So, routers not only replace the Stanley 45, which replaced wooden hand planes that were able to cut different profiles, but it also replaced what's called a router plane. And this is a router plane here. It has a little cutter on the bottom, and that goes into a slot, and you can use it to shape the bottom of a slot. So routers replaced the router plane. They can also replace very large planes to smooth out large boards that are too large to go through a planer and through a jointer. They can also replace various other style planes. Routers are quite versatile. They're probably the most versatile piece of equipment that you'll have in your shop. Here's another plane that a router would replace. And another one. These are old Stanleys, although this large plane is an old Bailey. I believe that Bailey merged with Stanley at some point. Routers can also, in some cases, replace regular saws. This saw is designed for cutting dovetails, and with the right jig, you can actually cut dovetails using a router. In addition to these tools, over here, you can't really see it on camera, I have what's called a hollow chisel mortiser. A router can actually replace this. This is designed to cut square holes in boards, to cut mortises, and then you can use something like a radial arm saw to create the tenon that would go into the mortise. With a router and the right equipment to go along with the router, you don't need either the radial arm saw to cut the tenon or this to cut the mortise. You can use just a router to do it. And so routers are quite versatile. They come in various sizes. This is a Bosch trim router. It's a Bosch Colt. Earlier I showed a cordless version of this. This is a corded version. I believe this is rated at 1 horsepower. And by the way, the horsepower rating on these routers is a little bit interesting, I guess you could say. I believe it takes 746 watts of power to produce 1 horsepower. So actually the most that you can get out of a outlet, a 120 volt outlet, is somewhere around 2 horsepower, maybe a little bit more than that. And yet, some of these routers that I'll be showing you in just a minute are rated at 3¼ horsepower. Of course, it's not unique to routers. You'll also see air compressors that are rated at 6 horsepower, or shop vacs that are rated at 6¼ horsepower. Those are ridiculous numbers. And anyway, it's a special rating that's given to tools that have what are called universal motors. Whereas these are usually a high-pitched motor, make a loud noise compared to motors like what are in table saws and various other equipment. So this is a small trim router or palm router. This is what I call a small router. This was manufactured in 1989. I purchased it used at an estate auction, and it was set up originally for cutting dovetails. I've removed the dovetail bit to use it in another piece of equipment, and as a matter of fact, I've got another router back here that's already set up with the router bit that I use with my dovetail jig. We'll be showing that dovetail jig in a later video. Next up, we have a mid-size router. This is a fixed base 2¼ horsepower Porta-Cable router. Sadly, Porta-Cable, which is owned by Black & Decker now, no longer produces routers. Before they were owned by Black & Decker, Porta-Cable was one of the top brands for creating routers. They produce some of the best routers on the market, and as a matter of fact, the templates that go into the bottom of those routers are often called Porta-Cable style templates. So this is a 2¼ horsepower router. It's a mid-size router. Anything typically between 1½ horsepower and 2¼ horsepower is considered a mid-size router. This has variable speed, whereas some of the other smaller routers do not have variable speed. Variable speed is critical, and we'll talk about that later when we talk about router bits. And this is what's called a big router. This is a 3¼ horsepower plunge router, also made by Porta-Cable. This is no longer made, obviously, because Porta-Cable no longer makes routers. But this is a big router. And earlier we saw that I used another big router, my Bosch 1611 EVS router, which I've put back up onto the shelf. You probably can't see it, but it's up on the shelf behind me. So there's different size routers, as you can see here. And you would use different routers for different purposes. So in other words, you would use a big router like this when you have a large router bit that needs to be controlled. This has enough power to control a 3¼ inch diameter router bit. Whereas this router might be able to go up to maybe 1⅓ inch, in diameter, and this just has a small 1/8 inch router bit in it right now. You notice that I kind of leave certain router bits in certain routers. This one has an 1/8 inch router bit in it. This one back here has a flush trim. This one has a slightly larger size roundover bit. And this one back here has a small roundover bit. So anytime I need a roundover bit of a certain size, I can just grab a router off the rack back here. And of course, I mentioned this one already has a 14-degree 1/2 inch wide dovetail bit that's used by my dovetail jig. I used to have a router bit permanently in this router, but since I've bought some other routers, I don't need to use that one anymore for that purpose. Give me just a minute to clear off some of these other tools from the workbench, and then we'll continue talking. In addition to routers being of different sizes, different physical sizes, they also have different characteristics that are important when you're trying to decide on which type of router to buy. For instance, routers such as a palm router or a trim router, some of them have batteries, some of them are corded. All of them will only take 1/4-inch diameter router bits. That is, router bits that have a 1/4-inch shank. I've got some here in this white side kit. This is a bottom bearing bit, similar to the one that I used earlier, except that this one has straight knives instead of spiral knives. This is a top mounted bearing. There's a small chamfer bit, and then a small roundover bit. I actually bought these to be used in trim routers so that I would mount these permanently in one of those routers. And then there's also a CNC kit, or they actually have a different name for this, maybe an all-in package or something like that. These are all 1/4-inch shank bits from Whiteside. All sorts of different patterns. There's a V-bit. And those will work in the trim routers. They'll also work in the larger routers. These larger routers, in most cases, will have both a 1/4-inch collet and a 1/2-inch collet. So they'll take both the small bits and the large bits. This is a fairly large bit. I think it's about 3 1/4 inches in diameter. Here's a slightly smaller bit. This is designed for cutting the edge of a door, of a cabinet door or something like that. No, I'm sorry. This is actually a bit used for a table edge. They make similar bits like this for cabinet doors, but this is actually for a table. And then also large flush mounting bits with a bearing on the bottom and also on the top. Now when I say bottom and top, this is the way you're supposed to be looking at it. Here's the bottom bearing and here's the top bearing. This router bit is a little bit different. It's got a spiral that goes in two different directions. It goes in one direction at the top and a different direction at the bottom to control chip out, both at the bottom of the board and at the top of the board. So getting back to the routers, the larger routers will take both a 1/2-inch and a 1/4-inch shank router bits. There's different styles of routers that take 1/4-inch and 1/2-inch shank router bits. The classic style, this is a 90th anniversary Porta-Cable router. I've got a couple of these. They have round handles, and the switch to turn it on and off moves depending on what you have the height set to for the bit. So one time it could be over here, and then when you mount a different bit, the power switch could be over here or on the back side even. So this is one style. I don't really like round-handled routers because you have to hold on to it with one hand to turn on the power. And sometimes these do not have soft start, which means that they'll jerk a little bit when they're powered on. So the round handle doesn't give you a whole lot of control when it jerks while you're turning it on or turning it off. Okay, so that's one style of the 1/4-inch and 1/2-inch. Another style is called a D handle. This puts a trigger switch to turn the router on or off right into a handle so that you can hold it essentially with one hand and turn it on and turn it off using just one hand. This gives a lot of control when you're using a router. This is one of my favorite types of routers, the D-handle, because it gives so much control. It's nice to be able to use a router one-handed. Now, this is one of my favorites, as I said. This is my favorite style that has a body grip style, is what it's called. A little tether here that allows your hand to hold it one-handed so that you can hold the board using your other hand if you need to. And you can use this to route just as if it were a big trim router. So that's a nice feature. These used to be made, this is the Milwaukee, it used to be made in the United States, but they've since moved the operations for manufacturing over to China, because China now owns the manufacturing operations for Milwaukee are located in China. That was after Milwaukee was bought out by another company that is located in China. And that happened several years ago. So these are the different styles for fixed base routers. And then there's also plunge routers. I showed a plunge router earlier. This allows you to release a lever and have it go up and down to make a cut into the center of a board. Now, as I showed earlier, you can actually do that using a fixed base router, but I had to sit down to use that fixed base router so that I was well anchored, so that I could rest my palms, if possible, on the board, so that I could easily drop the fixed base router into the board. This takes out all the pressure, and it's kind of nice that you're able to use this. You can also use this for doing edge profiling. I actually try not to use a plunge router for edge profiling, and the reason for that is that there's actually very thin rods in here that it rides on. These are actually a little bit thicker than some of the routers that I've seen that are plunge routers, and so the stability of the router may not be as good from the standpoint of quality of cut. Could be lower if you're using a plunge router to do the edge of a board, because there's not as much bearing surface or surface infrastructure in the router to hold it so that it doesn't shift slightly in a cut. So this is another style. This is once again the plunge router. And then there's a convertible style of router. This router, the 1617 EVS, is actually able to switch from being a plunge router. It's actually a small plunge router, because the distance that it can actually plunge down is about an inch shorter than the bigger router that I showed. And the bigger router is a Bosch 1619 EVS. I don't think that they make this anymore. I found this on eBay a couple months ago and I bought it. This router I picked up for $169 at the end of December. It was on sale at Amazon, and it actually converts from being a plunge router to a fixed base router whenever you need it. Now the question is, what type of router should you buy? Ideally, you would have both a plunge router that you could use and a fixed base router. If you don't have a whole lot of money for woodworking tools, then probably what you'd want to do then is to pick up one of these routers that you can convert from a fixed base to a plunge base router. They're economical. As I said, this was $169, which is quite reasonable. That's even less than what I paid for the Milwaukee router years and years ago, without considering the cost of inflation, what inflation's done to the value of the dollar since that time. So this is a convertible router. It may serve you well if you can only afford one router. If you can afford multiple routers, what I would strongly recommend that you do is you pick up a large router. This is called considered a 3 1/4 horsepower router, even though there's no way that you can get 3 1/4 horsepower out of a 120 volt outlet. So I would recommend that you get a large router like this, a plunge router, and then get a fixed base router like this one that you can hold on to with one hand, and you can route just like it's a trim router. If you're able to afford more than 2 routers, then I would also recommend that you look into getting a small trim router like this Bosch trim router. This doesn't have a whole lot of power to cut through things with large bits, but it's sufficient for roundovers and small 1/8 inch bits, maybe even 1/4 inch diameter bits. I try to use just spiral bits rather than the straight-eyed bits because you get a better quality cut. So these are the different types of routers that you'll encounter when you're searching for options. A lot of these routers you can pick up at significant discounts through other sources other than Amazon or a big box store. You could find good deals sometimes on eBay. I think I've picked up at least 15 routers through eBay in the last year, I'd say. I don't have a good count on the number of routers I've got. It's potentially over 30 by a couple. So anyway, there's different style routers, different handle styles. For these small routers, they've got an extremely small base, which is detrimental if you're trying to keep it from rocking. There's different companies out that manufacture different style bases for these small routers. And these are made in the United States. I found 3 different styles. This one is a Woodhaven. This one is by Make a Sign. So this has got 2 small handles. And this is a different style. This is created by the Wood Grain Junkie. So this actually turns this small router like this, or like this, into essentially a router that has a lot of control, just like a fixed base router. So something like that may be helpful for you. And in addition to that, this router accepts Portacable style template bearings or template units that I showed a picture of earlier. And that would allow you to do inlays quite easily. Unfortunately, this router's got a little bit too large of a center hole, and that's where this other base would come in handy. Okay, I'm going to clear some of this out, and then we'll continue. Okay, let's take a look at cordless routers and why it is that I do not recommend that you buy them. They seem like they'd be real convenient because you don't have a cord to dangle over your shoulder so that it doesn't get caught on anything. So that seems like that would be an obvious convenience factor to having a battery-operated router. The challenges with these, and there are many challenges, and I've got them written down here. These routers, compared with their cousin, the plug-in style, they're more prone to stalling out in use. Some of it may have to do with the size of the battery that's mounted on to the router. This is a 4 amp hour battery on this router. You can also get a 2 amp hour rated battery. I've got one of them back here for my drill. So that's another potential issue, is that different size batteries add more weight. The larger batteries especially add more weight up at the top whereas you want to have the weight of the router focused down near the bottom so that it's easy to control, so it's less likely to tip. So that is a disadvantage of these routers compared with these routers that have more of their center of mass down low. So that's the one advantage there. Another advantage is that the runtime of these routers is rather short. Now, by rather short, what does that mean? It could mean that you're going to get 15 minutes of runtime out of it before you've got to replace the battery, if you have a second battery. And if you don't have a second battery, that means that you've got to stop working after 15 minutes and put the battery on the charger again for several hours. So that's another disadvantage in a home environment. If you're in a work environment with these, you would probably have multiple batteries that are fully charged, ready to go, so that you can continue working. The batteries are kind of expensive, as I understand it. They're around $110 for a 4 amp hour battery. So that gets to be a little bit expensive if you've got to have 2 or 3 of these around so that you can finish up a project without having to wait a couple hours for the battery to charge. So the runtime is short. It's a little bit cold out in the shop because it's been cold for the last several days. I believe it's around 20 degrees today. It had been around 11 degrees for a couple of days. Battery performance in cold weather is rather poor. So you would not get much life or much runtime out of this battery when running in a cold environment such as my shop right now. They're expensive compared to plug-in routers. This router was selling on Amazon for about $80 very recently. This router, minus the battery, is selling on Amazon for about $210. You got to buy the battery also, which may be another $110, and then you've got to buy a charger to go along with it. So by the time you add it up, you may be close to $290, maybe $350 for a small trim router like this to be able to use it on battery power. So that's another potential issue. Another issue is that this comes with all sorts of nice dust collection capabilities. So you can hook it up to a dust extractor. And that's nice to keep the dust out of there so that you're not breathing in all sorts of sawdust. That's a nice feature, but that also means that you're going to be dragging around an 1.25 inch diameter hose with this router. If you're going to drag around a hose, you might as well also drag around a regular cable and just stretch this cable over your shoulder or around your neck and then plug it in. And that way you know if this is coming into some resistance, it'll tug on your head before it affects the quality of the cut. So that's not a limiting factor to have to plug it in. Another potential issue with these is that if you forget and you leave the battery plugged in while you're changing the router bit, that can be a dangerous situation for you because it'll turn on, whereas these routers, you're always supposed to unplug them from the wall outlet or from an extension cord before you change the router bit. So those are the different reasons that I don't think that these are suitable for a home shop. They might be suitable for a production shop, a cabinet shop, or something like that, once again, because those situations will have better resources to buy additional batteries to keep the tool running. Of course, you could do the same thing in your home environment, or if you just like working in 15 or 30-minute spurts. These are nice, convenient tools. The Bosch router is much more compact than the other routers on the market. A lot of the other routers, such as the DeWalt, are actually about that tall compared to the Bosch. And so that lends to much more top heaviness. This router, I was able to get it on a deal from Lowe's a couple days ago for $150, including the battery. Oddly enough, the battery is also compatible with my Bosch drills, which is kind of nice. But if it was not compatible, so one of the other issues that you could have is that the manufacturer stopped supporting the battery platform. I had a Bosch 24 volt half-inch drill, and Bosch simply stopped manufacturing batteries for it. Batteries went dead in the unit, and so I ended up having to throw out that $300 drill because I could no longer get batteries for it, and the batteries themselves would have been half the cost of the tool. And so it wasn't really reasonable to get additional batteries. So that can also happen with any battery-operated tool. If the manufacturer stops supporting the battery platform and moves on to something better, you may be out of luck once the battery dies and no longer takes a charge. So those are the disadvantages, once again, of battery-operated routers. Okay, let's talk about the parts of a router. On this body grip router, the motor is up here at the top. This is a 2¼ horsepower router. It has a variable speed control dial that's right here, and that's important to use when you're using larger diameter router bits. You turn down the speed as the diameter of the router bit goes up. So there's a switch here. These are called the handles, obviously, because you hold on to them unless you're using the body grip. There's a height adjustment on here. You've got to release the latch to be able to use it, and then there's a dial that controls the height of the router bit. And then when you've got it set into the position that you want to use it, you just close the clamp, and now it's locked down. This down in here is called the collet. This is a 1/2-inch collet in here. This is a 1/4-inch collet for the router. That it'll take the place of the 1/2-inch router. Some brands of routers, I believe DeWalt is one of those, they don't actually give you an entire collet when you want to use a 1/4-inch bit in a router. Instead, they give you a little sleeve that fits down into the 1/2-inch collet. I know that some people don't like that. Okay, let's say that I want to take out this router bit. I've got 2 wrenches here. Some routers only require a single wrench. This requires 2. This has what's called a self-releasing collet. And what that means is that when you break the nut free, you can't just pull out the bit. And you can't do that with a router that does not have a self-releasing collet either. As you probably saw earlier with the large Bosch router, I had this nut fully released and I could not pull out the bit. I actually had to tap on the side of the bit to get it to release. Well, this has got a self-releasing collet in it, so all that I need to do is put the wrenches down inside here. Get them set, and now I've got these oriented so that all that I've got to do is squeeze the wrenches together. This wrench here has to go toward me, and this wrench has to go that direction toward the camera. I just squeeze them together, and it releases. Okay, I cannot remove the router bit right now because it's still held in there. As I said, this has a self-releasing collet, which means that I have to turn this nut 1 or 2 revolutions, and then I've got to break it free a second time. So let me get the wrenches oriented correctly. Okay, so there I've got the wrenches oriented. Squeeze them together, and now I can take out the router bit. So there's the router bit. So this doesn't have 2 locks on it. Self-releasing collets require you to use the wrenches twice to break the bit free. And the second time actually pulls the router bit up ever so slightly to break the suction. And I'll bring these collets over so that you can take a look at them. Here's a 1/4 inch collet right next to a 1/2 inch collet. When you're trying to decide on router bits to purchase, router bits that take a 1/4 inch shank will be much cheaper than router bits that have a 1/2 inch shank. But you can see by looking into the ends of the collet that a 1/2 inch shank router bit will be much stronger than a router bit with a 1/4 inch shank. So it's going to be able to resist vibration and bending forces much better than a 1/4 inch router bit. So it'll produce a much better quality cut than a 1/4 inch shank router bit would do. 1/2 inch shank router bits are often better quality than what you'll find with a 1/4 inch shank. And we'll talk about router bits in just a moment here. Okay, in addition to the standard functionality here, you'll see that this has a black base. The black base is nice because it's got a nice wide opening, which means that I can use large router bits like this one in the router. They'll fit through the hole. Some routers will have a smaller center hole, roughly about 1.25 inches in diameter, maybe a little bit larger than that. So this router bit would not fit through. In addition to the standard black base, Milwaukee also sells a plastic base that's clear, see-through, and it has a smaller hole in the center so that you can use Porter cable style bushings with this base. And bushings allow you to create all sorts of pattern cuts, and we'll be talking about that in a later video. Okay, so next up, we're going to take a look at various router bits. Let me get these routers out of the way, and we'll start talking about router bits. Okay, let's talk about router bits now. There's hundreds and hundreds of different profiles of router bits that are out on the market. Some of those router bits are very good quality, and some are very low quality. I'd strongly recommend that you not buy low quality router bits. You'll find some on Amazon. I'll show you pictures of some sets that I found on Amazon. They're very low quality, made in China router bits, and you may run into issues. And I'll talk about some of those issues while I'm showing these pictures on the screen. Okay, one of the sets of router bits that I found on Amazon featured 40 different router bit profiles for $67. That sounds like a heck of a bargain. They're all carbide tipped router bits, and a lot of those router bits have bearings. Okay, so which would you prefer to have? A router bit from that set, where the average router bit costs less than $1.50 each, or would you have a router bit for $46 from a well-known company such as Whiteside, spinning in front of you at 25,000 RPM while you're cutting through wood? Okay, obviously, you would have to think, well, maybe the manufacturer of those Chinese-sourced router bits cut some corners, so to speak, in the manufacturing process to get the cost down from being $46 or somewhere in that neighborhood down to $1.50 per router bit. Okay, so some of those router bits in those sets, based on what I saw in reviews online, they may have undersized shafts that are 15/64 inches instead of a 1/4 inch in diameter. By the way, 15/64 is roughly the same as 6 millimeter. 6 millimeter is the shaft size often used for small router bits in the European nations. They don't work so well in 1/4 inch diameter collets. They'll actually fall out, and they could be very dangerous if a router bit falls out when you're using it. The bearings are often low quality. They may be off center. Those router bits will not be sharpened nearly as well as the high quality bits. Yes, they're carbide, but if the carbide is not sharpened properly, the bit is going to burn whatever it cuts immediately. So if you were to try to use one of these cheap router bits to cut maple, cherry, walnut, or one of the other woods that tends to burn easily, you would probably have difficulty using those cheap Chinese bits to cut that wood without it burning excessively. And of course, if the wood burns excessively, then you've got to sand the boards quite a bit to get rid of that burning. The carbide formula is of lower quality, meaning that the carbide will dull faster and may be prone to shattering when striking a knot or embedded metal in the wood. If you saw an earlier video, I struck, using my Foley bell saw planer, a piece of metal that was embedded in a board. You could have embedded metal in wood that you're using. Either reclaimed wood or even new wood could have embedded metal in it. And if the carbide strikes that, it may shatter if it's not made of the highest quality carbide. So don't buy the cheap sets. Even the least expensive Bosch sets are made in China. I believe that Bosch makes a couple grades of router bits. All of those router bits that I've seen are made in China. They may make some in other countries, but so far I've only seen that they're made in China. Just because they're made in China doesn't mean that they're of low quality, but if the bits cost only a couple dollars each, that's a sign that they're of low quality. As a general rule, I recommend that you do not buy bit sets. That says that you don't buy a set of 4 or a set of 20 router bits, but instead only buy those router bits that you think that you'll be using in the near future. That way you're not wasting money on router bits. Now, you saw in the opening that I have well over 100 router bits here of various different profiles. I don't use all those router bits frequently, but I have them in case I need them. I'll be demonstrating some of those router bit profiles later in the next video of the series, so that you'll get a chance to look at the different router bits. Okay, so now let's take a look at some white side router bits. I've got some pictures here showing various different styles of router bits. I chose white side because white side is a well-known brand that makes high quality. I'll put these up on the screens closer so that you can see them more easily while I go through some of the different styles. Okay, at the top left, you'll see some straight router bits. They have straight edges. And then next, the third one over is a 90-degree V-groove bit that's used for various things such as cutting signs. And then next to that is a core box, which is kind of a rounded nosed router bit. And then there's a point cutting roundover bit. I don't know if you saw one of my earlier videos where I had rings that were cut into a table's leg. I actually cut those using one of these point cutting roundover bits. Okay, next up, you'll see that there's a couple different spiral bits. Spiral bits have a significant cutting advantage over straight router bits like the first two at the left. They always have, or almost always have, a portion of the bit constantly in contact with the board that's being cut because of the spiral organization. Whereas the straight bits, they cut twice per revolution of the router bit. So they cut and then pause, cut, and then there's a pause again, and then cut again. That chopping motion causes a lot of excess of chip out that you don't get with the spiral type router bits. The spiral router bits are much more expensive, but they're definitely worth it so that you don't ruin boards. Some of the boards are quite expensive. So the first spiral bit that you'll see is an upcut bit, which means that as it's cutting, it pulls the chips out of the cut. That sounds great. One of the disadvantages of an upcut bit is that while it's pulling the chips out of the cut, what will happen is that the top of the board may suffer a little bit of chip out because of the upward motion of the chips coming out. They also make down spiral cutters that eliminate that. However, those bits actually force the chips down into the hole so they can create a burning problem where the wood burns rather than just being cut. So that could be a problem. One way that they get around that is they actually make combination spiral bits so that you've got an upcut on the bottom and a downcut on the top of the router bit. And so that eliminates both of those problems. I don't have one of those pictured here, but I'm sure that Whiteside makes those. Next to it is a 14-degree, half-inch wide dovetail bit, which could be used to make half-blind dovetails or even through dovetails. Next to that is a rabbiting bit, which is used to cut into the edge of a board. You can replace the bearing on it to cut in different distances into the board. And of course you can control the height to control how deep into the board it cuts. Okay, down on the second row, there's some different flush trimming and pattern bits, or template bits, however you want to call it. There's both the straight-sided bits, which once again, they cut twice on every revolution so that they're a little bit rough on whatever it's being cut, so you've got to be very careful using them. They make them in different heights because with a 1/4-inch shank, you're only supposed to cut 1/4 inch deep at the maximum. With a 1/2-inch bit, you can cut a maximum of a 1/2 inch deep per pass. So they make these flush trim and template bits in different lengths so that you can start out with a bit that just has a short cutter length on it, and then once you've finished using that with your pattern, you can switch over to either another router, or you can mount one of these bits that's like the third one into your router, and then you can cut another 1/4 inch deep with that router bit. And they've got bearings that are both on the bottom, which is a flush trim, and on the top, which is a template or a pattern bit. The fifth bit over, that's a combination. It has essentially a combination of a flush trim bit and a pattern bit. So they've got bearings both at the top and the bottom, and that's handy for different uses, such as avoiding different curves where the edge of the board could catch onto this type of a bit and rip out more of the grain than what you're wanting to actually cut. Next up, we're getting into the spiral flush trim bits, and these are much more gentle on the wood because they've got a shearing action to cut essentially at an angle, and because they've got a portion of the bit pretty much always constantly in contact with the board that's being cut, they don't have such a jarring motion, so you'll end up with a smoother cut when you're using a spiral flush trim bit or a pattern bit. So the first one is a flush trim bit with a bearing on the bottom. The next one is also a flush trim bit with a bearing on the bottom. However, this one has a unique twist. This is an up-down spiral. So on the bottom of this bit, near the bearing, is an up twist spiral, and then up toward the top of the bit is a down cut spiral. So this would eliminate chip out both on the bottom and the top of a board if you're cutting all the way through the board. So that's kind of nice. Next up are what Whiteside call ultimate spiral pattern bits. These are extremely expensive bits. I think that these are right around $180 each. They've got either a bearing on the top or a bearing both on the top and the bottom. And once again, the top is top of the router bit is the portion that you put into the collet. These bits have an up spiral at the bottom and a down spiral at the top of the router bit, so that they eliminate chip out if you're cutting all the way through the board or partially the way through the board. And so you can mount with the last bit there that has a bearing on the top and the bottom. You can have the pattern either on the top of the board or on the bottom of the board, as you saw earlier when I was cutting. Now, of course, when you use these at a router table, it's just the reverse. You would use the bearing on the bottom of the bit with a template mounted on top of the board, and then you would use the bearing on the bottom, on the top of the router bit with a template that's on the bottom of the board. So those are the general non-edge profiling bits, and I arranged these. Whiteside did not recommend this arrangement, but this is an arrangement that I selected. Next up, we've got profiling bits. Here's some of the different standards, or some of the different bits. I owned the majority of these bits on both the first and the second pages. So up here at the top corner at the left, I'm going to put this up on the screen so that you're able to see it easier. Up at the top left are the four most common types of router bits that you'll see for edge profiles. There's the classic roundover bit, and that comes in various different radiuses. This is a 1/2 inch radius that's featured. And then there's a cove bit, which is the matched pair for that. So in other words, you would be able to use a roundover bit and a cove bit together if you're trying to make a drop leaf table. So that's kind of nice. Next up is a Roman OG bit. Those are a common bit that essentially combine the roundover and the cove into a single bit. That once again is a quite common profile, and you'll see that pattern in the other bits that are at the top over on the right side, where they have both a cove and a roundover together with a little bit of a flat spot. The fourth bit is a chamfer bit, and that essentially just knocks the corner off the board, similar to rotating your table saw blade to 45 degrees. This is a 45-degree chamfer bit. They make chamfer bits in different degrees, different angles. Next up, there are classical bits and cove and bead, French traditional, OG fillet. And once again, these combine the first two bits, the roundover and the cove bit, with a little bit of a straight section in various different patterns. Down near the bottom left, you'll see various different edge beading bits. I own all three of those. There's a classical OG table edge bit. I showed that earlier in the video. And then if you don't like that fancy profile, they also make a traditional edge, table edge bit, and a thumbnail table edge, which is kind of like a stretched out roundover bit. Okay, in addition to those, there's also bits that are specific to cabinet making or making cabinet doors specifically. And I'll put this up on your screen much larger so that you're able to see it. And I'll just go through a couple of these. These are essentially matched pairs of bits that create the stile and the rail components. You would use one bit on the rail and the other bit on the stile. And in some cases, you would use one of these bits on the end of a board in addition. And they come in all sorts of different shapes and sizes, and essentially matching the second page of bits with the different profiles. So that's all the door bits. The majority of those that Whiteside makes. Whiteside also makes router bits that are designed for creating the raised panel in a raised panel door, and they come in all sorts of different shapes. The first bit is for doing a door edge, and then the second bit and all the rest on the top row are for doing the profile of the raised panel. And some of them are kind of smaller in diameter, such as 2.5 inches in diameter. Others are much larger than that. They go up to, I believe, 3.25 inches in diameters. Some of those have an integrated back cutter, and others require a separate back cutter bit if you want the raised panel to actually sit flush with the rail on the stile. Okay, you'll see that I've got a bit here. This is a kind of a fancy profile, and you'll see that there's a little bit of a rounded section here at the bottom of the bit. You've got to be careful when you insert these into your router that it doesn't make contact with that rounded section, because that means that the straight section of the shaft doesn't actually have good contact with the collet. When you're inserting router bits, what you want to do is you put the router bit in, of course, to the collet, and you let it go in all the way. And then what you need to do, so that it doesn't, that radius doesn't affect anything, you need to actually lift the router bit up between 1/16 of an inch and 1/8 of an inch and lock it in. You don't ever want to have the router bit sitting out like this with only a little bit in the collet. You always want to have it in as far as it'll go, and then bring it back out ever so slightly. There's kind of a levering action. If you have this router bit out too far, the router is not designed for a force way out here at the end. Consider if this router bit was much longer, like the router bit that I've got that I used earlier that's actually 4 inches long. It's not designed for a lot of cutting force being applied way out here at the end. The bearings that are inside here may end up getting damaged if you don't have the router bit back in as far as it'll go. So that's from a safety perspective, and also making sure that you've got enough of the bit into the collet so that it locks down tightly. Okay, so I'm going to go lock down 4 different profiles of router bits into 4 different routers, and then we'll cut a couple boards using these profiling bits. Okay, we'll start with a 1/4 inch radius roundover bit. I'm using some bench cookies here to raise the bit up, to raise the board off the table, because the router bit will actually strike the table, at least with some of these router bits, because they're so tall. So let's get started here. I'm going to start on the end and then go all the way around. I'll have to move the board over because the bench cookies are a little bit too wide to allow me to make one continuous pass. Okay, there's the roundover. And I actually set the router bit a little bit deep, which gives a nice little reveal right here, instead of just being a regular roundover. Okay, next up we've got a cove bit. This is a large cove bit. Let's get these other routers out of the way. And this is just a little bit unstable, but we'll try our best with it. Okay, I've got the router ready to go. Start on the end grain. Okay, there's the cove bit, the type of cut it produces. Okay, I need to swap over some electric cords to the other two routers. Give me just a moment. Okay, this is a French traditional router bit. Let's cut using that. And then we'll go over to this OG fillet. That's the second one that we'll be using. Bunch cookies are going to be a little bit of a problem here, but we'll do what we can. They're a little bit too wide. Okay, this is the French traditional. Okay, the OG fillet. Okay, that's all for today. Thanks for watching. Bye.